with scatter plots last week. So this week we're working with scatter plots again, but this time we're finding the line of best fit based on the scatter plot itself. So the first thing we're going to do is, if you have not downloaded the notes, go ahead and download them, print them so that you can fill them in with me. If you do not have a printer, you can also just pause the video and write some of the main ideas from the notes in your notebook, some of the vocabulary. So the first one is an outlier. So it gives you the word there, but it goes here also. The outlier is a point that doesn't seem to fit with the rest of the data and has a value that is very different from the other data points. So looking at the scatter plot over to the right-hand side, notice that one of these dots is far away from all of the other dots. So we can see that this is kind of a negative correlation because all of the dots are kind of going downward here. But this dot out here is the outlier, because it's away from all the other points. So sometimes you're going to see these kind of random dots that are very far away, so we can kind of just ignore them for this part of it because we really want to know what the majority of the points or the data is doing. Okay, so just keep that in mind as we go through the best line of fit. So the next one is the line of best fit. So a line of best fit, so that goes in that blank right there, that's what we're defining. A line of best fit is a line that most accurately shows the relationship between two sets of data and has about the same amount of points above and below the line. An equation for the line of best fit is written in slope-intercept form. So we're working with y equals mx plus b. So just like we did in previous weeks when we were studying the y equals mx plus b and solving different things, we're going to still be using a slope for m and a y-intercept for b. So those are some important things that we're going to need to know. So now we're going to look at writing an equation for the line of best fit. So let me switch this down so you can kind of see a little bit more. So the first thing we're going to do is estimate the y-intercept. And remember, the y-intercept is your b value. And draw a line that goes through the middle of the data. And that's going to be our b value. We're going to put it right here. So let me zoom out a little bit so you can see this whole graph. So based on this graph here, I'm going to take my ruler, and I have all these data points, but I want to find a y-intercept. So with my ruler, it's a positive correlation, so they kind of all go up. I want to find a point that's easy for me to identify. So if I follow my ruler, look at this point right here at 40. If I follow most of those points right through the center there, I end up getting a y-intercept of 40. So I'm going to go ahead and just draw my line. The other thing you want to look at are points along this positive correlation. I'm looking for points that I can pinpoint and find data from. So this point right here in the middle, this point here, those are good ones that I can draw my line through to try to find a line that goes through some of the points, but is kind of a best fit for that. So in this case, our b value right here would be 40. What that also tells us is that our line of best fit equation, the b value over here, also is going to be 40 because we're using y equals mx plus b, so b is 40. After you've drawn the line of best fit, you can estimate, what do you think we're going to estimate? We're going to estimate the slope of the line from any 2 points on the line. So we're going to choose 2 points on the line and use a table to find m, because remember, slope is the same thing as m here. Okay, so m is going to be, here's something new that we haven't done before. We know that we're doing the y2, I'm going to write that over here, the y2 minus y1 over x2 minus x1 like we did before. Well, we can say that is the change in y over the change in x. So this little triangle means the change. So it's the difference, basically. So the change in y over the change of x. So we know that we have the point 0, 40. That was this point right here. And now we need another point. Switch this up a little bit. We need another point on our graph to give us another point in our table. So following along, I liked that point right here that crosses in the middle. And that value right there is 370. It's about 370. I'm going to write that in my table. Okay. Now we can use our slope formula to find the difference, or you can just look at the chart and say, what's the difference between 0 and 3? And that's my x value. It's going to be 3. And the difference between 40 and 70 is 30. Okay, and it's positive, so I know my slope has to be positive. So this is the same thing as 10. So my slope would be 10. Now, if you wanted to do it mathematically and use your slope equation, you would take your this would be your x1, oops, that would be x2, x1, this would be your y1, y2, and you'd plug it into your equation. So 70 minus 40 over 3 minus 0. And that'll still give me 30 over 3. Okay, so we're just using this slope formula that we did a couple weeks ago. All right, so now I know my slope. So that goes right here in my equation. So my equation is y equals 10x plus 40. Okay, so we're going to continue doing that. Let's look at a bigger example. So the second page of notes, I can find it here. There we go. So the second page of notes gives you a table that they want you to actually plot. So let's do that together. So we're going to create a graph, label the x and the y axis. So we know this is my x, this is my y. Now looking at my table, it says the number of hours working out and the total number of pounds lost. So this is my x, this is my y, because the number of hours working is going to give us the amount that we lost. Okay, so y is the dependent, x is the independent. So x is the number of hours working out, where y is the total pounds lost, okay, or the total weight loss. So let's go ahead and write that into our chart over here. So this is the weight loss. And then x is our hours working out. Okay, so our second step there is to graph the data from the table. So we're going to go ahead and plug these into our graph. So we have 28 for our hours. These go, notice, by 2. So here's 28, 10, 5, 4, 8, 6, 9, 3, 14, 5. So go ahead and if you need to pause the video and graph, you can, or just work along with me. 29, 22, 7, 3, 2, 24, 10, and 12, 5. Okay, so if you're not quite finished, pause the video, finish your graphing, and then we will move on. So from there, we're going to go ahead and interpret the data. So the data shows that we have an upward trend because all these kind of move upward. So this is an upward trend. It represents a positive correlation. Okay, so we learned that last week. It's positive, it's going upward. As the number of hours working out increases, the total pounds lost also increases. Okay, so as the number of hours working out increases, the number of pounds lost increases also. So that makes it a positive. So what does it mean? It means the more you work out, the more weight you're going to lose. The more you work out, the more weight you lose. Okay, so that's the first part. The second part is actually writing the equation of the line of best fit, which we're going to be doing this week. So let's look at that. So we want to estimate first step here, estimate the y-intercept and draw the line of best fit. Okay, so let's look at our graph. Again, I'm going to take my ruler and I need to find an estimate. So I've kind of got these 3 dots in the center of my graph here. And I'm kind of going to go off of those because I've got a few above, a few below. So if I kind of come through here, let's line those up. I go about to 1 right there. That's about my line of best fit. So I'm going to make my B value 1. I'm going to draw my line up. All right, so my B is going to be 1 because right at this point here, 0, 1 is where my y-intercept is. Okay, so let me slide this back down. So my y-intercept is going to be 1. So that means it's y equals mx plus b. This is also 1 right there. Now we're going to create a table and find the line using 2 points. So we're going to find the slope. Okay. So we need a second point. So our first one is going to be 0, 1. Okay, and we need another point. So look at this. It actually went through this point right here. So that's 12, 5. So let's use that as our second point. It's right there. You see it? So in our table, and we are estimating. So if yours ends up being a little bit different than mine in your homework, that's okay as long as it's very, very similar to it. Okay, so we have 12, 5 as our slope. So now we need to find our change in y. So remember we have y2 minus y1 over x2 minus x1. Let's identify what we have here. This is my x1, y1, x2, y2. So let's plug it in. So we have 5 minus 1 over 12 minus 0. All right, so we end up with 5 minus 1 is 4. 12 minus 0 is 12. So we end up with a slope that is 4 over 12, which is the same thing. We can divide by 4, and get 1 over 3. So this is going to be my slope. So my slope is 1/3 x plus 1. So that's my final answer. This is my line of best fit. Okay. Then at the bottom, we have an interpret and apply section. So we're going to estimate the number of pounds that would be lost if you worked out for a total of 15 hours. So we're going to use our equation that we wrote to figure this out. So if our equation is y equals 1/3 x plus 1, I'm going to work it out over here on this side here. So we have y equals 1/3 x plus 1. And we worked out for 15 hours. And remember, x is the number of hours. So we're going to plug this in for x. So we're going to have y equals 1/3 times x, which is 15, plus 1 to find out how much weight loss you would have. So we get y equals 15 over 3 plus 1. 15 divided by 3 is 5, so y equals 5 plus 1, and we know that that equals 6. So y equals 6. So 6 pounds. You're going to lose about 6 pounds if you work out for 15 hours, according to this graph. Now we're going to estimate the number of hours worked out if a total weight loss was 8 pounds. So if the total weight loss is 8 pounds, that's not my x anymore, that's my y. So now that's my y. So I'm going to plug it into my equation. So if my equation is y equals 1/3 x plus 1, I'm going to plug 8 in for y. So 8 is equal to 1/3 x plus 1. And now I need to solve for x. So I'm going to subtract 1 from both sides. I end up with 7 is equal to 1/3 x. And then to get x by itself, we need to do the opposite of this. So we can multiply by 3 on both sides and get 21 is equal to x, because these cancel out. So 21 hours it would take to lose 8 pounds.